Good afternoon. So in the previous class we are discussing about that is VI characteristic of thyristor. We have discussed different mode of operation of thyristor. Today we will discuss that is thyristor turn-on method. Okay. So there are different method of turn-on method of thyristor. One is forward voltage triggering, gate triggering, dV by dt triggering, temperature triggering and light triggering. So let us first discuss about forward voltage triggering. We will first discuss about forward voltage triggering. That is forward voltage triggering and gate triggering we already know. Let us first discuss about forward voltage triggering. So in the thyristor I am having what? PN layer, and this is what? Anode, and this is what? Cathode, and this is gate. Okay. If anode is given positive supply and cathode is given negative supply without applying any gate signal, suppose I am not giving any gate signal, then some amount of leakage current is flowing in this condition, because what? G1 is forward bias and J2 is forward bias, but J3 is forward bias, but J2 is what? Reverse bias. As J2 is reverse bias, what is the current? Current is 0, but some amount of leakage current is flowing. But if I am keep on increasing the voltage at a voltage known as what? Breakover voltage, junction J2 breakdown occur. If junction J2 breakdown occur, because previously J1 and J3 is forward bias, but due to junction as the junction J2 is reverse bias, so current was not flowing, current was only leakage current. But when the junction J2 is breakdown occur, then current start flowing. Okay, so when the voltage up to VBO, then current start flowing. So this is known as forward voltage triggering. Okay, when I am giving the voltage up to breakover voltage, then junction J2 breakdown occur. If junction J2 breakdown occur, then current start flowing. Okay, from anode to cathode. Okay, it is known as what? Forward voltage triggering. But generally giving the voltage up to VBO is not recommended, because it may destroy the device. Okay, so next we will discuss what? Gate triggering. It is PN 4 layer, anode and cathode, and this is gate. Okay, so in the forward blocking mode, what is forward blocking mode? If anode is given positive and cathode is given negative, it is forward blocking mode. In this condition, J1 and J3 is forward bias and junction J2 is reverse bias. Okay, but as I know that the VBO requirement to turn on the thyristor is very high. Suppose I am taking the 400 volt thyristor, the VBO requirement, the VBO voltage is around 2 times, that is 800 volt. So normal working voltage, what is the normal working voltage here? 400 volt. So in the normal working voltage, the thyristor in the forward blocking state only, because if I am not giving any gate signal to turn on the thyristor, I require voltage up to VBO. Okay, and which is generally very high. So at the normal voltage, suppose not in the normal voltage range, suppose I am taking a 400 volt thyristor, so here the breakover voltage is what? 800 volt. So normal voltage range, the thyristor is in forward blocking state only, because here J2 is reverse bias. So to have conduction of thyristor, I am giving what? Gate supply in between gate and cathode. Okay, gate is given positive and cathode is given negative, so that as I know that N region is heavily doped, so as it is connected to positive, the P region is flooded with electron because of this heavily doped N region. Or it may chances that some of the electron may crosses the junction J2, may break the junction J2. Okay, and the what is the voltage requirement here depend upon the magnitude of gate current. If the gate current increases, so definitely voltage requirement is reduces. Previously, suppose here the voltage was 300 volt and some amount of gate current was flowing. Suppose now I am increasing the gate current, means what? The voltage requirement is now reduces, suppose 200 volts. Again, if I am increasing the gate current, the voltage here requirement is reduces here. Okay, so the voltage requirement here is depend upon the magnitude of gate current. If the magnitude of gate current increases, the voltage requirement is reduces. Okay, so no need to give the voltage up to VBO. At lesser voltage also I can trigger I can turn on the thyristor by applying the gate signal. Look here, so when I am not giving any gate signal, what is the voltage requirement? VBO. At this point the thyristor will start conducting, but when I am giving the gate supply, suppose at this point I am giving the gate signal, so what is the voltage requirement here? Reduces, it is less than VBO. So what is the voltage requirement here? It is reduces, and the thyristor start conducting. It will follow the path like this. Okay, it will start conducting. Okay, so the voltage is now reduces due to the application of gate signal. Okay, suppose it is gate current and it is forward voltage. Suppose it is forward voltage. So I have seen that when I am not giving any gate supply, when I am not giving any gate supply, what is the voltage requirement? That is equal to VBO. When the gate I am not giving any gate signal, then gate signal or gate current, then what is the voltage requirement to trigger the thyristor or turn on the thyristor? It is VBO. But when I am increasing the gate current, what is the voltage requirement here? Look, here the voltage requirement is reduces. Here the voltage requirement is reduces. Okay, if I again increasing the gate current at this point, suppose I am increasing the gate current, again the voltage requirement is, look here the voltage requirement is reduces here. If I again increasing the gate current, here the voltage requirement is again reduces. Okay, so I have seen that when I am keep on increasing the gate current, the voltage requirement is reduces. Okay, but it is required to give at least some amount of voltage in between anode and cathode, and this voltage is known as finger voltage, that I have already discussed in the previous class. That is known as what? Finger voltage. It is all about what? Gate triggering, which is very reliable. Okay, next let us discuss about dB by dt triggering. Okay, so in the forward blocking state, when I am not giving any gate signal here, in the forward blocking state, it is anode and it is cathode, it is junction J1, it is junction J2, and it is junction J3. So in the forward blocking state means what? Anode is connected to positive and cathode is connected to negative. In the forward blocking state, I know that junction J1 is forward bias, junction J3 is forward bias, but junction J2 is reverse bias. Okay, so all of the voltage is blocked by J2 only, because this is forward bias, this is forward bias, and this is only reverse bias. So total voltage is blocked by the junction J2. Okay, and this reverse bias junction J2 has a characteristic of what? Capacitor, due to the charge existing across the junction. As it is reverse bias, due to the charge existing across the region, it will act like a capacitor. Okay, and suppose the capacitor junction, the capacitor value is Cj, that is junction capacitance, because here junction will be formed and that junction capacitance is suppose Cj, the junction capacitance is Cj. Then what is the current? Current is nothing but rate of change of charge dq by dt. Okay, then what is q? Q equal to Cv, so I can write d by dt. C, capacitance value is junction capacitance, just now I have written. And what is the voltage? Suppose here the voltage is V, or anode voltage, suppose here I am writing A. Okay, anode to cathode voltage. Okay, then I can write what? One is d Cj by dt, and one I can write that is Cj, that is dV by dt. Okay, generally the junction capacitance is constant, so derivative of constant equal to 0. So this term equal to 0. Okay, then what is I? I equal to what? Cj, that is junction capacitance, dVa, that is voltage Va. Okay, Va by dt. Okay, if the rate of change of voltage is high, means if the rate of change of voltage here, what am the voltage I am giving, if the rate of change of voltage is high, then the current is high, it may turn on the thyristor, but it is undesirable because it may unnecessarily turn on the thyristor. Okay, so it is undesirable, that is dV by dt triggering is undesirable, because if the rate of change of voltage is high, then it may turn on the thyristor when I am not required to turn on the thyristor. Okay, it leads to what? Undesirable turn on of the thyristor. So next we will discuss temperature triggering. Okay, so again this is anode, this is cathode, this is P and P and okay, and this is gate. Okay, so in the forward blocking state, forward blocking means what? Anode is positive and cathode is connected to negative. So this is junction J1 and this is junction J3 is forward bias and junction J2 is reverse bias. But I know that though the junction J2 is reverse bias, some amount of leakage current was flowing. I have seen some amount of leakage, because in the graph I have seen that what? Some amount of leakage current was flowing. So this is the some amount of leakage current was flowing. The graph was like that. So some amount of leakage current was flowing, and this leakage current leads to rise in temperature of the junction. Okay, because this junction is reverse bias, some amount of leakage current was flowing, and due to this leakage current the junction temperature is rise. Okay, and I know that if the temperature of the junction is increases, then again the leakage current is increases. Okay, here the leakage, if the temperature is increases, again the leakage current is increases. So it is a cumulative process. First leakage current was flowing, due to the leakage current temperature of the junction increases, and due to the temperature increases, then again leakage current is increases, and again leakage current is increases means what? Temperature is again increases. So it is a cumulative process. So it may turn on the thyristor at high temperature. Again it is undesirable, because at high temperature it may damage the thyristor. Okay, the last is what? Light triggering. Okay, again it is anode cathode. So when anode is given what? Anode is given positive, cathode is given negative supply, and in this process in a recess or niche is produced in the inner P region, because it is what? P and region. So a recess is made in the inner P region, and where light intensity is eradicated here. So it is act like as if I am giving what? Gate supply here. So due to the light injected, a hole and electron injected in the P region, it may what? Break the junction J2. It may break the junction J2, and it is same as if I am giving what? Gate supply in between gate and cathode. Okay, type of triggering, this type of SCR when I am applying light triggering is also known as light activated SCR. Okay, light activated SCR. The application I can say it is used in generally HVDC transmission line, high voltage DC transmission line. Okay, the application is HVDC system. So let us try to solve few question. Look, first question is thyristor is a dash carrier semi control device. First tell me what is semi control device. Look, if one thyristor is there and here anode and cathode, and I am giving what? I am giving here positive supply, and here I am suppose giving the gate supply. Here I am giving the gate supply. When the thyristor is turned on, no need to give the gate signal. I can remove the gate signal now, because I have already told that when thyristor is conducting, then once the current is more than latching current, when the current is more than latching current, no need to give the supply of gate supply. Then it's known as semi control. Means what? I can control the turn on. Okay, I can control the turn on, but I cannot control the turn off. Once it is turn on means if I am removing the gate signal, still only it will continue to conduct. Okay, so I am not having any control on turn off time. Okay, so it is known as semi control. Okay, a thyristor is a dash carrier. It is a majority charge carrier or minority charge carrier? It is definitely a minority charge carrier. So a thyristor is a minority carrier semi control device. Why minority? Because here both electron and hole and electron will take part in the conduction of thyristor. Okay, so it is a minority carrier device. Look, a thyristor can conduct current in dash direction and block the voltage in dash direction. Okay, I know that thyristor is a unidirectional device because the current can only flow from anode to cathode, like diode. In the diode also current can only flow from what? Anode to cathode. But what is thyristor? Extra gate circuit will be there. In case of thyristor also, current will always flow from anode to cathode, not from cathode to anode. So I can say the thyristor can conduct current in one direction only, that is from anode to cathode, and block the voltage in both the direction. Why both the direction? Because when I am not giving any gate signal, still only it will block the voltage, because when I am giving the voltage up to VBO, then only it will conduct. So before VBO it will block the positive voltage, and also in the reverse bias condition means when anode is given negative and cathode is given positive, so junction J1 is reverse bias and junction J3 is reverse bias, so it will not conduct. Okay, so in the forward direction also it is blocking, and in the reverse bias condition also it is blocking. So I can say block the voltage in both the direction. Okay, next question. A thyristor can be turned on by applying the voltage greater than forward what? Breakover voltage. So a thyristor can turn on by applying the forward voltage greater than forward breakover voltage. The voltage will be forward breakover voltage, then only it will conduct. Or by injecting a positive gate current, because if I am not giving voltage up to VBO, then I require gate current. So injecting a positive gate current pulse under forward bias condition. Okay, in the forward bias condition. Clear? Next, to turn off a thyristor, the anode current must be brought below dash current. Okay, to turn on the thyristor, I have already told that the current should be below one current, that is known as holding current. So the answer will be holding current. So if I am keeping the anode current below holding current, then only thyristor will turn off. Okay, next question. Thyristor may turn on due to large forward, that is dV by dt. If the dV by dt is, if rate of change of voltage is high, then it may turn on the thyristor. Clear? So today we will discuss 5 methods how to trigger the thyristor. Next we will discuss switching characteristic of thyristor. Okay, and this is the answer which we have already discussed now. So next class we will discuss. Okay, thank you.